For this assignment, we're going to be looking at changing velocity. So up until now, most of the velocities we've been talking about have been constant, or we've been talking just in general. Now we're going to look at some numbers, and that gets things more complicated. So go ahead and answer these first two questions. When we're considering an object's position, what must be established? List 4 scenarios for possible changing velocity situations. And then you're going to have some scenarios down here. So I'm going to go ahead and just give an example, generic, and we're going to go through this. So first of all, for these objects A, B, C, and D, you're only going to be doing one of these. Okay, so you're going to first say what's going on with these scenarios. Are they speeding up, slowing down, moving positive, moving negative, so on and so forth. Okay, when you get over to here, you're going to plot your points. So I already kind of set it up so that I have my distance and time graph ready to go. So I'm going to plot 40, then 20, then 10, then 5, and then 3. And I'm going to have a nice curved slope. Okay, easy peasy. I'm also going to have you do this in Desmos, and I'm going to show you how to get a function that will give you the tangent. Now on Google Classroom, I have the common fits for physics that we've been using. You're going to use that one to make your graph, and this copy of tangent line you're also going to use. So I have them already prepped, so you can pause and get to the point that you need to be in. Okay, so I already put in my data over here. That's the stuff that I made up to use just for an example. It doesn't fit perfect. Yours should fit better than this because I did not make sure that the graph was going to fit square perfectly. But yours should be really close to fitting. So I'm going to use this. This is my best fit graph. I have my information for my A, B, and C down here. I need to take the equation. So when you plug in the A, plug in the B, plug in the C, you're going to take this information and then you're going to go to the copy of tangents file that I gave you, and it's going to look like so. Now when you come to here, it gives you the directions up here. So when you pick a power fit, then it'll give you the value for A. You're going to need that. You're going to plug your equation in here. So I have the tangent line graph up. So it already has this 5x squared. If you read through this, it basically tells you take your equation from Desmos from your graph ring 1 right here, and you're going to plug it in. Now I made it simpler so that I wouldn't have to go back and forth between screens, and I typed it in here so that I'm not having to go back and forth. Now it's set up as having the 5x squared to start. You're going to copy all of the information, make sure you have the x squared and the x, and you're going to put it after this function portion. And it's going to go ahead and create your graph over here. Now what this does is, let me get rid of this because I don't need it anymore. Make sure when you're typing it in, if you copy and paste your numbers, that's totally fine, but make sure you have your x squared, make sure you have your x. If you don't have it typed exactly like it's supposed to, then it's not going to come up over here, right? And it may not give you the tangent that you want. So the cool thing about this is this actually gives you the tangent now. So what would be difficult to find changing velocity now is no longer hard to find, because this red line here is the tangent. So you'll notice my numbers here are changing as I'm changing the tangent. So my A value is actually where I'm at on the x-axis, and this is my value for my slope. So what I'm going to do is I'm going to bring it to 1, and I'm going to see what my slope is as I get to 1. So here's my 1. Now what I'm going to do is I'm going to document my numbers so I can make another graph, because I want to make a velocity time graph. So I'm going to go ahead and take the same numbers that I have on the worksheet, my 1 through 5, and I'm going to get my values so that I'll be able to plot my velocity time graph here. So I'm just going to go to get the slope for the 1, the 2, the 3, 1, 2, 3, 4, 5, and I'm going to get my values so that I can plot what it's going to be on here. Now my first value is going to be 1, which is what my A value is, and then negative 20.6. Okay, so then I'm going to go ahead and go to 2. Oh. Okay, 2, and I'm going to have negative 14.75. I'm going to keep doing that through number 5 because that's what I need to graph on this sheet. And I do want to stress, make sure that you pause as you're completing stuff to do the parts that I'm showing you. Okay, so I ended up with these numbers here. I just wrote them on the side of my paper. I went ahead and I did graph them. Now this doesn't look very straight, but I went ahead and I put it in Desmos also. And if I look at my Desmos looks pretty darn straight. So if I go ahead and come down to my graph, I'm going to switch to a linear fit because it does look as straight as it does. Turn that one off. Oops. And I've got a pretty good linear fit. And with this, since this is my VT graph, the slope of this represents my acceleration. So that means my A value here is representing my acceleration. So that's, whoops, up here, 5.83. So then, since it's going to be 5.83 for the whole thing, since it's a nice straight line, then my acceleration for my whole graph will be 5.83. Okay, so now I've got, since all of my points would be 5.83, I went ahead and I put the 1, 2, 3, 4, 5, and then 5.83 for each of them. So then I can go ahead and graph it, and I'd be approximately here. And then I can graph my acceleration. Oops. Helps if I label it right. So that's A and T, and that is my acceleration. So I actually have a uniform acceleration at 5.83. When you're finished with that, you can go ahead and it's going to ask you to do a motion map. Then it's going to ask what are the limitations of the graphs, and a couple other questions just asking about what if this. So if you don't get this completed, we can have more time tomorrow, but I know it's a lot. See what you can get through. If you need more time to finish up the acceleration graph, that's fine. And when I was in Desmos doing the acceleration graph, I just went ahead and I saved this as U3 worksheet 1. I have the graph one saved as graph, and then I have another one for the tangent that I just called like tangent after it or something. But I went ahead and I just put both sets of data here. Make sure that if you do that, that you change your X1, Y1 so that it's X2, Y2 for the first set of data that you had. So here's my first set is still on there. I just have it turned off. And then you've got your X1, Y1 for the recent set. So that way you could go back and forth and just change your X1s, Y1s so that you can look at the data that you're hoping for. If you have questions, let me know. Otherwise, I'm hoping this video will lead you right through it.